All right, we want to talk about finding a slanted asymptote from a rational expression. So one of the things that we can do is factor the expression, as you can see I've done above, and find the holes in the expression. So here we have a hole at x equals 2. Now, I'm not really going to go finish the hole out, but what we want to do is we're going to talk about that reduced equation. Right, once you've reduced the equation, multiplying it back together gives you a much simpler equation. I don't have that extra factor involved, and it's going to make that long division process a little bit easier. So here's how we're going to do that. We're going to take the denominator of the fraction, and we're going to put it in, and we're going to put the numerator inside the division. Now, in order to do this, you're going to do long division. And we always think about long division in terms of the first terms in each one. So I'm going to look at this value and this value. I need to know what value to put up here, and it'll be this thing times this object to get exactly this first term. So sometimes it's obvious, sometimes it's pretty intuitive what to multiply by. But when those times are a little tricky, clearly we're going to multiply by x, but I need to know what that coefficient is. So we need to multiply -3 times some, we'll just call it y, some number, and that needs to equal +1 because we're looking at a +1 x squared. I've got the x squareds working out. X times x is x squared, but if it's not obvious what to multiply by, you can set that up like this. We're going to divide both sides by -3 here, and so that coefficient needs to be -1/3. So -1/3. In this case, anytime that you have a 1 for your coefficient, most often you're going to be multiplying by the reciprocal of whatever value you have. So here and you have 3 and then 1/3. So that seemed obvious, but sometimes you may have multiple values involved, and it's nice to be able to set up this little mini equation and solve for it. So when I multiply through here, we're going to get x squared minus x. So -1/3 times 3 gives me that -1. We're going to change our signs and add these things together. So you get 0, and we're going to get -3x, be plus 0 in this case. I bring down the 0 because I want to have two terms here. I want to know what that next number is, even though when I put something here, when I multiply by that 3, I'm going to get a second number. So it's always good if you run out of digits here, bring down a 0 just as a placeholder. Okay, so this one's easy. It's going to be +1. 1 times -3x is -3x, and we want that first product to always be the same number and the same sign. Next part will be 1 times 3. It's going to give me +3. Change our signs here and add them together. Then we end up getting a -3 as a remainder. Now, we know when you do this process, especially with higher ordered polynomials, like when do I stop? Well, the thing I'm looking for is when the degree here, this is a degree of 1, is when this degree is bigger than this degree. So this is a degree of 0. You have you don't have an x value here. You're out of variables. So the constant has a degree of 0, and so here you have a degree of 1. So this is a larger degree than this because you can't multiply something times x to make it become nothing. So we're done, and this is the final result. We have a slanted asymptote at y equals -1/3 x plus 1. Now, just remember, when you graph slanted asymptotes, I'm just going to focus on graphing this asymptote, not the whole function. We're dealing with linear functions, so you have mx plus b as the form, at least that's the form you want it in. If it's not written that way, definitely rearrange it so that it is. So we have a slope set up here as -1/3, and we have a y-intercept of +1. When you graph linear functions, you always start off with the y-intercept first. So we're going to go up to +1 on the y-axis. I'm going to graph a dot. I'm going to put a dot there. And I'm going to use my slope. Remember, this is rise over run. So rise means you're talking about going up and down. Run is left and right. Because it's negative, I know that my graph needs to lean to the left. My line needs to lean to the left and go down to the right. So when I have a negative slope, what I typically do is I just simply choose to always go up, and then I'm going to go left if it's negative, right if it's positive. And I only need 2 points to graph a line. So we're going to go up 1 point, and then we're going to go over a few points. We're going to go up one value and then over 1, 2, 3, and this is my secondary point. Now, if I did the other direction, I would go down 1, and I would go over 1, 2, 3 times and put a point here. It doesn't matter which way I go because they're all going to line up in exactly the same way. So once I've done that, I'm going to line these 2 points up, or 3 in this case, and I'm going to kind of sketch in that asymptote. And that's how you graph slanted or find slanted asymptotes.